Hi, my name is Mark Wong. I've been involved in the Postgres community for 20-some years, doing various things, being some technical and not so technical. I'm here to tell a story about performance testing around the use of a company's data model, the experiences they had when things went wrong, and how they were able to carry on. The points I'm hoping to make with this presentation is performance testing is important. Please don't use the EAV data model. And if you have to use it, there are ways to survive with it and make it work. And that there's not always a single best solution, so you may have to experiment to find the best way to deal with the situation when you have performance problems. So this company was a marketing company. They helped their customers track information about their clients, such as their email address, their name, favorite database. You can also and any other attributes that the customers want, such as favorite fruit or whatnot, but we'll keep it simple in this presentation. So once upon a time, back around in 2010, the original data model horizontally partitioned the database by customers. And each partition had over a dozen tables, using table inheritance. But only one of these tables contained information about the client data. So exporting the client's data was fast and easy, and this is the main performance test that we're talking about. So here's an example. One of the commonly performed tasks is to export the customer's data into a CSV file. So their email address, all their attributes, the data for each of those attributes. And very easy to write, very easy to use the copy command to export that data into a CSV file. Customers can expect to export all of their data within seconds. But there were still problems with other parts of the system, even though this part ran really well. So with over 40,000 customers, this resulted in over 1 million of objects in the system catalogs. This made it really hard to mine the data to generate the simplest reports. It was also very difficult to administer the system. If a customer wanted to track additional things like favorite fruit, it would be very difficult to use an altered table statement because of how many objects were in the database. And it was very hard to generate backups of the database. So a query as simple as just counting the number of people were in the system to just simply count rows was very painful for the rest of the system because the query had to acquire 40,000 locks to perform such a simple query. And if you were to attempt to do a more complex query, join two tables, now you need 80,000 locks, another table, over 100,000 locks. This database had under a terabyte of data, but it takes pgdump over 24 hours to create a backup because of the number of objects in the system. So the company decided to do something dramatic. First thing they decided was to reduce the number of partitions by fixing the number of partitions into roughly 1,000 different partitions. So we reduced the number of tables from 40,000, or sorry, not tables, number of partitions down from 40,000 to 1,000. This also balanced the data and all the partitions to roughly 1 gigabyte each. And it was also at this point that the EAV data model, which I'll describe next, this is at the point where the EAV data model was applied to one of the tables. And with the EAV data model, it was decided to create a homegrown Python middleware layer to deal with data transformations between the web server and the database system. And I'll illustrate that in a little bit. So the EAV data model, short for Entity Attribute Value Data Model, in short, is basically a relational data model that lets you have unstructured data. It's easy to represent in an entity relationship diagram. You have 3 tables. On the left with the entity table that describes the client, the individual, a unique identifier with their email address. The attributes table on the right-hand side will have all the data, such as the data that you want to collect, such as the name of the data that you want to collect. So the first name, last name, favorite database, favorite fruit. And the relation table value in the middle will have the actual values, and in the column that properly represents the data type. So Postgres, Durian, and whatnot would be in that column. What was known before rolling out the EAV data model was that it did increase the number of tables from 1 to 3, but that was okay since we reduced the number of partitions from 40,000 down to 1,000. We knew we didn't need to use alter table statements to add additional attributes to track. We can now use insert, update, delete statements. But for cons that we're willing to live with was that the data needed to be queried differently, and that Python middleware layer that I mentioned before, something needed to be developed to handle the different format of the data. And a minor detail was that handling the strict data types could have been handled by multiple tables, but it was opted to handle that by multiple columns. So this is what the data looks like when using the EAV data model. Now, instead of having 1 row per client, you're going to have 1 row per attribute tracked. And the data needed to be transformed back in order to export it. So I think that all of that sounds pretty straightforward. But now that we can take a look at the performance, the significant factor to look at when considering the performance is the number of rows that you're going to deal with. So the largest customer was tracking 1 million clients and tracking 120 attributes per client. So that would produce over 120 million rows. The next largest customer produced over 100 million or about 100 million rows. And number 3 was significantly smaller at 700,000 rows. So how long does it take to export? Bukai. So all the exports failed. No customers were able to export any of their data now. Queries were taking too long. We would disable the statement timeouts, but then the queries were still taking so long that the web server was timing out connections. And even increasing the timeouts on the web servers, then the network switches were timing out because that's how long these connections were staying open and not transmitting any data. So what we did to try to isolate the problem further was to rip out the Python code out of the web server and execute it directly on the database system. What we found was that it was taking over 4 hours to export the data for a customer that was producing only 700,000 rows. these customers that had over 100 million rows was taking, I believe, over 12 hours. But after a certain point in time, we just consider that it was not possible to collect data or to export their data. So there was a little bit of crisis management at this point. It was not an option to go back to the previous data model. The next steps that were taken were to trust the database to be able to do what it's good at, to be able to handle large volumes of data. So we looked at the crosstab function, the crosstab functions that were provided by the table funcs extension to be able to pivot the data in the database. Just to illustrate the query, if I can make it fit on a slide, it means that it's very straightforward to write, and we won't be walking through won't be walking through the details of the query. So was using crosstab function a positive experience? It was able to transform 120 million rows in about 22 minutes, 100 million in 17 minutes, and the customer with producing 700,000 rows was able to get their data in about 10 minutes. So much faster. Company was able to continue doing business for the time being, but there were still some trade-offs. The exporting data was taking tens of minutes instead of seconds, but the company was able to live with that. Small exports were taking a little bit longer, but I think that's a minor detail. ORMs at the time were not able to natively abstract the data. If the database was pivoting the data, not a lot of ORMs were able to abstract that into models. So additional work had to be put into the Python middleware layer to handle that directly. And not all the problems were resolved by using the crosstab function. Importing data into the EAV data model had similar problems that the crosstab function didn't address, but we're going to ignore that for the purposes of this presentation. And we discovered that with additional testing, if customers were growing closer to having 5 million, growing from 1 million clients to 5 million, that the crosstab function will run out of memory and fail. So we had to do better, and the company asks, what if we just remove the data from the database? They were basically asking us to explore a unstructured data option. So we can prototype that in Postgres. The first item, the first solution that we looked at was using the HStore extension that provided the HStore data type, which allows key value data and key value pairs to be stored within a single column in a database. There were a couple of trade-offs that we knew off the bat that we thought were we would be able to live with. So everything would be stored as strings. We would lose the ability to have strict data types. We wouldn't have any referential integrity constraints. And at the time, not a lot of Python database libraries supported HStore natively. So if you haven't seen HStore before, this basically allows us to store all the attributes within a single row again. We would add a new column back into the entity table to store all of the data that was being tracked per client. This is an example query that I can still fit on a slide just to illustrate that it's straightforward to write a query to transform data from the EAV data model to HStore, but more generally, something very similar could be written to transform the data to any key value data store. And exporting the data is pretty simple. It looks almost as simple as just copying the data straight out of a table, as in the original data model. So now, how fast is it? We can get the time to export data down to 15 seconds again. Well, it's still an order of magnitude larger than the original data model, but 15 seconds still looks significantly faster than 10 minutes, and definitely significantly faster than 4 hours. So the lessons that were learned in this were that the EAV data model, please don't use the EAV data model if you can. Retrieving and inserting data performs very badly, especially when you start approaching 1 million rows. So in other words, if you don't think you're ever going to have 1 million rows, you could probably be okay living with the EAV data model. We learned that doing data transformations in custom written Python code was okay until we got to hundreds of thousands of rows. So if you could still do it, but you needed to be aware as the data set grows, it's going to be very difficult to continue managing that. Another interesting side effect that we found with the EAV data model was that it increased the on-disk size of all your data by 50%. But if you're in the unfortunate position where you already have the EAV data model in place, have a lot of data, you can improve the application performance by making use of the crosstab function, or even using HStore without having to actually store the data back into the database. Transforming the data out of the EAV data model on the fly using HStore can happen in seconds. One thing that wasn't around at the time was JSON. So if we were to do this again today, taking a look at how JSON would help with using JSON instead of HStore would have been an interesting experience, and we would expect the outcome to be fairly similar. So that is my story. Thank you. 谢谢。